Hi everyone. Today I would like to talk a little bit about a project that my friend and I were building for the past year or so. As you can see, the name is COD, and it's the Rust web framework for lazy developers. I guess many of you are lazy. We too are lazy, and yeah, we build a framework or are building a framework for people, I guess. So the plan for the presentation is to talk a little bit about ourselves, then to do a quick feature highlight of the framework, and then we can do a little demo, and at the end we'll talk about the challenges that we faced when building the project, and roadmap, and if you want to get involved, then we can talk a little bit about this as well.
And you are not afraid to make the demo, right?
What? Sorry?
You are not afraid to make the demo.
We're always afraid.
You should always be afraid. Yeah. But anyways, yeah, this is me. I'm Mateusz. I'm an open source contributor. I've been using Rust for the past 5 years. I'm a huge enthusiast of the language. Unfortunately, not commercially yet, but this is soon to be changed. I'm also a daily driver of daily driving GNU Linux for the past 15 years, I think. In my free time, I tend to participate in cybersecurity CTFs, and sometimes I also play Richie Mahjong on some tournaments across the Europe. Yeah, that's pretty much about it.
And hello, my name is Marek. Most of the things that I have here are similar to Mateusz, because we do a lot of things together. I also contribute to open source. I also use Rust and Arch Linux for quite a long time, although a bit shorter than Mateusz. Currently, I'm working as a Go software engineer, unfortunately, but it is what it is. And previously, I worked as a security engineer, doing some hacking and stuff like that. But okay, before we go into code and why the heck we have written yet another web framework Rust, let me paint you a picture of how the ecosystem looks right now. In general, the web development ecosystem is fairly mature in a, let's say, global sense across all the languages. There are many big frameworks in many different programming languages that are used for plethora of different applications. They provide a lot of features that are built in, that are easy to use, that streamline that the process of building that application and making it simple and easy. And as a result, they support many different use cases. They support many different approaches to building applications and different architectures. And also, with them being on the market for so long, they've been well benchmarked, well tested, they are working well, working fast. The problem with Rust is that we don't have anything like that, or at least we didn't when we started working on the project. As you can see here on the quote from RWebYet, one of the many pages related to Rust, is that most of the Rust web development ecosystem consists of many small modular frameworks that are mostly at the web server level. They're not at the whole web application framework level. And if you want to do anything bigger, then you have to wire everything yourself. However, since that time, something has changed. For example, local REST is one of the ones that we know that is trying to fill that gap. I think also Pavex is the other one that is also trying to do similar thing. But yeah, as I said before, when we were starting this project, it wasn't a thing. So that's why we did it. And yeah, I went a bit too fast, but both of us have written quite a few web applications in Rust. Mateusz quite a lot, me quite a few as well, and it was really annoying that every time you have to glue everything up together by yourself, get the web server, first choose the web server, then choose the database layer, glue everything together, set up authentication, set up users, sessions, models, all of that. And if you're doing one after another, it gets annoying, it gets repetitive. So we were frustrated with that and decided to do something with this. Also the time was good, as the Mateusz was going to have a lot of free time. So we just thought, why not? And let's just do this. And this is how COD, our project, started to exist.
Yeah, so let me introduce the project. So COD is a batteries included backend web framework for Rust. It has been inspired by Django. If you ever done something in web development in the Python world, there is a high chance that you know it. But yeah, basically the idea is to provide as friendly developer experience as possible by just providing solutions to common web development problems and packing them inside a single, nicely integrated package. So we have stuff like authentication, we have in-house built ORM for the database access, we have pretty much automatically generated admin panel for the database models. We have a template system, error pages that I'll hopefully show in a minute. We have support for HTML forms, but also for, since we are building a framework for 2025, we also have support for RESTful APIs, and we can automatically generate Swagger UIs or other open API backed UIs as well. And yeah, much more, hopefully in the future. But yeah, let's have a look at the features. So yeah, as I mentioned, we have built or are building an ORM because, again, we were not exactly happy with the current state of the ecosystem. So yeah, the idea is that you don't really have to think neither about writing migrations or what's exactly the underlying database engine are you using, at least for most of the stuff. The Rust structure is the source of truth, and after you define it in your source code, we have a CLI tool that can automatically see the difference between the last state and what you have currently in the source code. And it can automatically create migration that will create it in the database. We have a query API that has been designed so that it's as close as possible to regular Rust code. So we have this nice little query macro. And you can see that this dollar sign basically means that we are referencing columns in the database, but the rest is whatever we want. For example, we have regular Rust function call here, and it gets translated into SQL code and executed.
And as Mateusz mentioned, we have an admin panel. So if anyone of you have used Django before, we know that admin panel is one of the best things that you get out of the box, because it's simple, it works, it allows you for an easy access to the database without actually going into SQL and doing everything yourself. So we thought that we want the same feeling, the same ease of use of application and database, and we decided to implement admin panel ourselves. The way models are created with our model macro, but the way to actually register our model with the admin model is just you need to derive two things, at least at the moment, is the form macro and admin model. And that's basically all you have to do. And after you do this, and when you go to the admin panel in your browser, you should see the models that you have registered in the admin panel, And then when you go to them, you can see you would see what you see on the screen, which is the list of all of the instances of that model in the database. Right now it's fairly bare bones, but it's pretty simple to expand, and this is what we're planning to do in the near future. The other thing that we do is we have pretty error pages. None of us love debugging. It's pain in the ass. We all know this. So when you have to do it, when something not working, it's nice to have the errors easily visible and clear so that we can quickly find the source of the problem. That's why all of the errors that are caught within the framework, within the development mode, are going to be nicely present on the error page, which you can see here. We show stuff, panning data from stuff, backtraces, diagnosis from the framework itself, like the rules that try too much on the request data, and so on and so forth.
Yeah. Another thing that's very useful when creating backend web services is the templating engine. So we integrate with something that's called Ascama, which is again, it might be fairly similar to familiar to you if you've ever used Django. But Ascama is a template engine inspired by Jinja 2 that allows you to build HTML by combining HTML with some special control flow blocks. And the nice thing that we have that, for example, Django doesn't, is that it provides full type safety. So, for example, as you can see, it's a template. It's an example of a template. You can see HTML tags, but they are combined with these if, for's, and other stuff. So at compile time, this is converted into Rust code. So if something doesn't match, if you have types that do not work with each other and stuff like that, you can see that before you even run your app, which is super nice. And similarly to that, we have full support for HTML forms that we can create from the source code. You just create a Rust structure, add a derive macro, apply to it, and you can literally render it as HTML as a single line in your Scama template. Obviously, it's not very well suited for like production applications because it lacks some customizing features. You probably want to eventually rewrite it anyways, but it's super useful for prototyping.
And yeah, as Mateusz mentioned, we're trying to do the framework worth 2025. So right now, if you ever use API, you know that Swagger logs are amazing tool for you to learn the API, to use the API. But it's not always easy to generate them from web application because different frameworks have different support for that type of stuff. So we decided that there's yet another thing that we would love to have in a framework, so we implemented it as well. As you can see here, we have two Rust tracks that would specify the request and the response that you would get from the possible handler. The only difference for that track that you need to do to make it work with our Open API generation is to derive just one more macro, which will do all of the JSON magic for it to properly serialize and deserialize. And then here, when you register your root handler with within your application for a given path, the only thing you need to do is you need to change the function within the root and the function for the method. So you can see here the only difference is that we're using with API handler and we're using API pods that do all of the magic behind the scenes to generate all of the required data for us to generate that Open API specification. And here you can see what it generates for a single handler that takes for a single handler with a body and a response.
Okay, so time for a demo. The idea was born from the times that we were members of one of the clubs at our university. So the idea is to manage club users' cups. So people bring cups into the club room, and they often forget to clean them up. So the idea is to generate some QR codes that you can stick on the cups, and if you see a cup that has not been cleaned up, you can scan the code and see who is the owner. So yeah, during the demo we'll try to demonstrate some features that we were talking about, so like the ORM and like creating models, interacting with the database, a little bit about user management, admin panel usage, and the open API specs and the Swagger UI. So yeah, this is publicly available by the way, so you can, if you want, you can have a look either now or later. Okay, so okay, so I have this here, but before we do that, so as I think as I think I mentioned, we have a CLI tool that's just called COD. It has a bunch of utilities inside. One of them is just COD new, which creates a new COD project. So I will just use it to show you how a typical application written with our framework looks like. Also, actually, it's instantly, but yeah. Basically, what you can see here is first of all we have support for like TOM configs. So you can configure your like common things that you typically want to configure at like runtime, and you obviously have support for like development and production configs. When we have a look at the main file, we can see there is a bunch of boilerplate, mostly for like registering all of the stuff together. But you can also see that there is this template here, which also we can have a look at. Here it's just like HTML, but so like it's not terribly interesting, but I will show examples of some more interesting stuff in a second. We also have something that's called Bacon. I mean, it's not our tool, it's like external one. But it's super useful for web development because it allows us to do a live reloading of the app when you change the source code. So when I do bacon serve, I can open the app here, and when I do some changes, for example here, and just save the file, it gets updated in a couple of seconds. So that's super useful. But yeah, anyways, the demo app. So I have it here. I will not do the live coding because it's not terribly. It's not really a trivial app, but I will show the features by doing some steps after, like in each step we'll add some more features. So yeah, as you can see, we have pretty much the same structure as before, but we already registered some additional stuff, like the admin app. Like actually run this so that you have something to look at. Yeah, and yeah, as you can see, we already have an example of one of the error pages that Marek was talking about. Because we don't have any endpoints registered except for the admin panel and the Swagger UI, we have this not found error, and yeah, you can see all of the interesting stuff here. But yeah, we can go inside. Oh, nice. The admin panel, and as you can see, there is already one model to manage. So this is the just the admin account that I can change here. But yeah, let's try to add some actual content. So in order to do that, we just add a structure called cap. It will have some metadata inside. So for example, the owner of the cap, the name, which can be whatever, and whether it's present in the clubhouse. Yeah, that's pretty much it. And when actually I don't want to do that. What I want to do is go to the scan step, and when I go here again, you can see that the cap is here, but we didn't do the migrations, so we have an error, and you can see it's not very nicely rendered here, but yeah, you can see all the details about the errors and the entire error chain. And there's backtrace, which is unnecessarily long, but it is what it is in the Rust land, especially in the async Rust land. So yeah, we don't have the migrations. So what we can do is just to do code migration make. And when we do that, we see that there is this file that's been automatically created that just creates the model with all the fields inside. This is just a regular Rust code, so if you want to change something inside, you can do it. And yeah. And yeah, when we go here again, we can see, yeah, that the caps are here. So yeah, let's try to add something. And yeah, perfect, it works. Yeah, so let's try to do something. For example, we can try to display them outside of the admin app. Before I do that, let me remove the migration down. And yeah. So the idea is that we will create a actually I can hide this. Yeah. So we will try to create a view with a template inside. The template will just, like the view will just query the cap from the database and will just display it. And you can see the template over here. So basically, yeah, as I mentioned, the idea is that you have HTML combined with these special tags that correspond to some Rust codes that return some data that you want to display. So again, now when we go to here, we can see that there is this new route being added. So when we try to visit cap/1, you can see that the cap we just added to the admin panel is now displayed here, and we have a nice QR code as well. The next step would be to have some form that would allow us to add a cap outside of the admin panel. So this is just what we will do. As you can see, we have, I can't see because it's here. So yeah, it's a very simple form that just takes a name, and yeah, what is probably the most interesting is that there is just this single form derived macro, and what we can do in the template is just use this form tag, and when we try to run this, again we can just I didn't have to do that, but yeah. Yeah, we have our form here, and again we can create another cup, and yeah, yet again it's being created, and when we go to the admin panel we can see that it shows up here as well. Next step, yeah, why don't we, yeah, for completeness we should probably implement scanning the QR codes as well. This is fairly similar to what we've already done. Yeah, not sure if there's, probably there's not much more interesting stuff than that, except that, of course, in forms we can upload files, and yeah, let me show that. So again, we go, actually, because I don't know the URL, it's just easier to cause a 404 error, and oh wait, it's scan. Yeah. Yeah, except we don't have the QR to scan, but we can just do a screenshot. And yeah, let's just put it here. Yeah, when we try to scan it, yeah, we see that it actually opens the cup that we wanted. And yeah, last but not least, we can try to build an API that we could, for example, use to create an actual single-page application later. So this is what we do in here. So as you can see, we just create a regular view as well. What is important is that in order to generate these open API specs, we need some way to tell the type system that we are using some kind of data. So for example, here we can see that we have this special JSON structure, both as a parameter, which in this case would mean the request body, and as the response. Thanks to that, we know that this view will always take a JSON as an input and outputs a specific JSON to the client, and you can see the structures here, of course. And what's most interesting is that when we go to the Swagger UI, you can see that it indeed ends up being displayed here. And you can also hear that the request body and the response actually correspond to the Rust structure that we defined. So we can obviously try to add some, actually not strings. And yeah, when we execute that, we see that it actually responded with our new cup. And again, we can go to the admin panel and log and sign in for the 100th time today. But yeah, we can see that this cup has actually been added as well. So yeah, I think that gives you a general idea about how the code looks like and how easily you can add stuff, and yeah, how much of like automation we want to do. Yeah, back to the presentation, I guess. So yeah, let's talk a little bit about the challenges that we faced during the development of the project. So the first challenge is async. So async is a difficult topic in the Rust land, mostly because it's notoriously annoying to use, and the ecosystem is pretty mature, but it's not that great. But yeah, let's talk about the good stuff. As it was mentioned already earlier on during one of the presentation, the async is implemented using state machines, which are very performant. It's pretty much as little overhead as possible. So yeah, we have the nice blazingly fast Rust performance. The ecosystem is pretty mature. It's not super great, but it's very mature. Async has been existing for quite some time. And it's suitable even for embedded systems, which is again like proof that the implementation is actually very performant. But yeah, it's also that the bug traces are not very useful. You could have seen that in when I was showing the error page. The bug trace is huge, and it's mostly like Tokyo stuff. So it is somewhat useful, but not very useful. Sometimes it's difficult to reason about, although it's probably true about most of the concurrent code. There are some weird compiler errors, like why is my function not input future output something plus send, which are not very beginner friendly. You also have to use thread-safe structures or single-threaded runtimes. In case of Axum, the HTTP library that we based our framework on, it's not even an option. Like, you cannot use single-threaded runtimes, but we have some plans to migrate to Hyper, which is like one level lower than Axum, that actually allows to do that, which should make it a bit more beginner friendly. And yeah, there are some other really weird quirks, like for example, your state machine might end up having like 50 kilobytes of data because why not? So yeah, it's sometimes annoying.
But yeah, whenever we talk about big projects, there's always this question of maintenance. How do we create it? How do we keep it? And how do we keep it running for a long time? So code is mostly written by Mateusz. He has the most skills and the most time to do it. I try to help him as much as I can with some additional feature work and mostly with reviews and maintaining the repo as well. However, we still consider this project as both. All of the bigger decisions are made collaboratively in agreement. And also, we need to remember that writing a web framework from scratch is not an easy job. And I don't think we were actually fully aware what we were signing ourselves for when we started it. So what we're trying to do is we're trying to get some help from outside. That's why for example, that's why we're here. That's why we have Mateusz is writing about code on his blog post. That's why we're trying to post about code on different social media. We're posting on Reddit, on Rust Forum, on Blue Sky, on This Week in Rust newsletter, and probably a few other things that I just forgotten. So it's always nice to have this project, but there's always this hidden work that you need to do to keep it running.
So yeah, what did we learn by building the project? A lot of stuff actually. I will go through all of, probably not all of them, but the major ones at least. So the nice thing about building a project like this is that you, whether you like it or not, you will learn about the language internals. So for example, we learned how async works in Rust on a much deeper level than I used to. We learned how Axiom, Rocket, and other web frameworks and libraries work. So we learned the ecosystem. We learned how to design APIs that will be useful for other people to use, basically. In this kind of project, you need to think a lot about this kind of stuff. You cannot also unwrap errors everywhere, and you need to think about that as well. And it's surprisingly difficult to create APIs that are actually that will actually be usable by people, because you don't know pretty much anything about their use cases, and they might be vastly different from what you might expect from them. There is a lot of macro-heavy code that we use to both to reduce their boilerplate and to bring some cool features. It's not common that you can write a bigger project mostly by yourself in daily job, because it's usually more collaborative. So it's also nice to do something like this, of this scale. Here on the slide it's 30K lines of code, but I think it's closer to 40 right now. The different ways to test. We have a lot of stuff. We also have this fancy Selenium-based test that would just run a regular web browser and click on buttons and see how it works. So yeah, that's super cool. Also, what we learned is that even though the project was very much unfinished when we published the 0.1 version, we decided that we want to talk about it and publish news about it on sites like Hacker News, Reddit, and the Rust forums. So there was a lot of feedback that wasn't very useful, but there was a lot that actually was. I think there's it's good to show off a project in early stages, so that if you make bad decisions, somebody will come and complain about them, because otherwise you can just keep building on top of them and tragedies might happen. And yeah, something that gives me bragging rights probably. So there is this kind of common, opinion, especially if seen online, which is basically that computer science degrees are useless, and I do not agree with that. I literally have proof in the project, because I had to implement some of the typical computer science algorithms. But yeah, I generally think that these courses actually teach you how to think. But yeah, anyways. So as I've mentioned, the project is still in the early stages. It would be super useful if you could have a look at it. We have some apps that are already powered by code, and surprisingly, it was we didn't have really much problems with them, even though they are not very popular. It's not a serious use. But yeah, I think the type safety and other cool features of Rust make it really easy to write bug-free code, even in large code base. But yeah, the plan for now is to build some more web applications using code and try to demonstrate that it's actually useful for some bigger projects as well. So yeah, the roadmap. We have a lot of stuff that we want to do. So for instance, the automatic migration generation process is not very it's not great. It lacks some features. It doesn't support many of many operations that you want to do. There is some stuff in the core infrastructure, like for example, background tasks and scheduling. The admin panel, as we mentioned, is pretty much bare bones. We want to add search, filtering, and probably some customization options as well. The access control, so like we don't really have any sort of the generic permission system, so we want to do that. There are front-end web frameworks in Rust that would be nice to integrate with. So like Leptos, Diaxus, and Vue are the most popular ones, I think. The Diaxus guys recently created something that's called a sub-second library, which is basically a hot patching library that allows you to annotate your functions essentially, and when you change the code inside them, the like runner can hot patch them without reloading the entire app. So that would be a huge win for us for like the developer experience, because especially in like bigger projects, recompiling and especially linking the entire app can take up some time. But yeah, with that it would be like you could iterate in like and then see the results in like half a second or something. And yeah, there are many more plans, but yeah, that's probably something that's worth telling about now. So yeah.
But okay, we've talked a lot about the project, we've talked a lot about the features, the problems, the roadmaps, but now what we want to ask you is if you can help us and how you can do this. There are many different ways. First thing, of course, like the most obvious with the open source project, you can just try to contribute. We try to keep our GitHub issues very well documented. We use labels to make sure that you can easily find something easy to work on to contribute. The plus of first project like that, there are a lot of things that you can either easily add because they're just missing the obvious parts of missing parts of something bigger, or you can just create from scratch something that might not be always possible in like big projects that have mostly everything already built in. And there are many different ways. You don't need to just add the code. You can add documentation. We have the code recipe that Mateusz mentioned, where we create a guide. If you just want to improve the guide, that's also something great that we would appreciate. If you want to keep touch with us and the project community, which is slowly growing, you can join our Discord, which you can access via the QR code or the link below, or just from our website. The other thing is that, of course, as any project, we appreciate any financial support, because it allows us to, for example, get those nice stickers and magnets that after the presentation, please feel free to come and take. That allows us also to maybe focus more on the project, to allow us to go to conferences, share more about the project. So it's always nice if someone also wants to support financially. And the other thing that might be actually the easiest is just try it yourself. Try to create some simple application, see what works, what doesn't, and just let us know. For example, I'm trying right now to use code for one, I think, more advanced application so far, the most advanced application so far with code. And in the few first steps, I found many missing pieces in the code, and actually it was on the train back from the Rust Week conference that we've been. And during that train ride, I was able to find like 3 or 4 different things, and half of those are already implemented or like are within the open PR. So we're welcoming any comments about the issues you have or anything that's missing, because we want to hear that, because that's what allows us to focus our effort on something that users actually want and need. And the other thing you can do is just you can spread the word. You can share our posts. You can show it to your friends. You can just give a star on GitHub and allow us to have those beautiful graphs like that. So yeah.
Is this Hacker News spike on this?
Yes.
Yes. Yeah. It's one open line release with the Hacker News Reddit and other posts. Yeah.
We've been refreshing the GitHub page, I think, like every 5 or 10 seconds, and it was great seeing like 5 more, 10 more, 50 more. Like it was going crazy fast. It was beautiful to watch. And while it's going a bit slower, we still appreciate every new star that we get, because it gives us the information that this project is interesting to someone and that it is still worth working on it. And yeah, that is all. Thank you for listening to us yap about this project for so long. And if you have, I guess this slide got missed, but if you have any questions, we're happy to answer them right now. Anyone?
Okay. Very impressive work. Thank you very much for this presentation.
Thank you.
A question is about have you thought of an elevator pitch for your project? Like, for example, Rust language has these two keywords: performance and safe, and these are repeated everywhere as a, let's say, elevator pitch. So, what kind of elevator pitch could you come up with here? Is it yet another web framework? Probably not, right? So what are you focusing on? Is it for easy prototyping? Is it for performance servers? Or do you think you can come up with something here?
So the tagline we've gone for, you can see here, is the Rust web framework for lazy developers. We're using that before because it shows that lazy developers just want to get things done as quickly as possible so they can go back to doing actually fun stuff. So that's what we're trying. We're trying to do all of the annoying, boring things so that people that want to create things can go straight to creating things, not to trying to figure out which library I want to use here or there.
Yeah, I would just also want to add, because you mentioned performance, so performance is not our priority. I mean, it's not like we deliberately want to make it bad, but if we have like a choice between good developer experience and good performance, we choose the first one. So yeah, basically we are trying to build a web framework for people that want Rust's qualities, like type safety and like all the goodies that make your apps pretty much bug-free, but with some of the, some of the ease of use of like web frameworks for high-level languages, like in Python or something. So yeah, this is our goal.
And just a last note, you care about performance, but we take the use of use, we put much more focus on use of use. And the nice thing that why we can actually do it is because Rust is just performant. So we're actually not doing that much on focusing on the developer experience, because Rust by itself is blazingly fast, as we all know, so it gives us that good baseline of good performance that we can always like improve on in the future.
But does it mean that this framework targets like Rust developers or all developers? Because Rust is famous famous from its steep learning curve, right? So let's say random developer probably wants learn Rust to use your framework, right? So is it targeted for just Rust developers that wants to create some web app?
We're targeting it to everyone who wants to build a web application in Rust quickly. We're trying to simplify that experience with creating it in a way that it's easy to use, but also by creating the guide that I mentioned before that allows people to quickly get speed up on the way that the code works. So yeah.
Okay, thanks very much.
Okay, other questions? I think you were the first I saw, so.
How does the ORM handle field renaming?
Okay, so the short answer is it doesn't at the moment, but the long answer is the idea that we want to, like how we want to do it is kind of what Django, like similar to what Django does. So basically, when you rename a field or a model or whatever, you try to match the old model, like every old model with every new model, see the how similar they are. So for example, you can see that almost all of the fields are the same except for the one which is also the same but has like a different name. So the idea is to generate some sort of similarity score, and based on that, ask the user, for example, if the similarity is above some threshold, ask the user if they wanted to do a rename, and based on that, either create a rename operation or a remove plus create operation, if that makes sense.
Okay. So the today you for example add a new field. Do you generate like an actual migration file, or you? Yeah. Okay.
I can actually show that if.
It's fine.
I just want to point out to sum up. Basically, it's heuristics, asking user, and also you always have this backup cache of the fact that our migrations are actually pure Rust code that you can modify. So after generating migration, you can always take a look at the generated file and see, well, it doesn't what I really wanted. You can always modify it by hand and make sure it does what you want.
Yeah, so as you can see, I've just created a field in an existing model, and after I run the CLI tool, you can see that, and it just creates a new file with an add field operation. So yeah, just do a difference between the old and the new model and act accordingly to that.
Any other questions?
Yeah. So like you said previously, that's really impressive to see something like that. So yeah, amazing work. The question is, would you expect that we will see, let's say, maybe not too distant future, some greater Rust adoption when it comes to web development, or do you think that basically doing any sort of like a memory management, even like by fighting, let's say, the borrow checker, is basically, at least at this point, is too much for web developers, even for backend web developers?
Yeah, that's a very good question. So yeah, the ecosystem, I think the ecosystem is the biggest problem right now, because the language itself is kind of annoying to work with in this kind of environment, but there are some projects that people are doing. For instance, the one I mentioned, the Diaxus guys that implemented hot patching, which is literally a feature that has been pretty much only available in high-level languages. Now it's, yeah? I mean, yeah, high-level and dynamic languages. And now it's here in Rust. So, yeah, the borrow checker is annoying to work with. On the other hand, there are also some libraries that make it sort of easier to use, so that you don't have to use borrow checker and other there is this library, for example, called just bytes, I think, which is basically a high performance vec of U8s that you don't ever have to borrow it because it has very smart implementation that has vtable for implementing the actual either cloning or reusing the existing buffers. Sorry, I probably didn't explain it too well. But yeah, what I'm trying to say is that the ecosystem is rapidly evolving. So I think we should see some more adoption in the future. And yeah, this is our this is something that we also part of the reason why we are trying to build this project is to make it easier for people.
And yeah, as Mateusz mentioned, the ecosystem is rapidly evolving and growing. Our project is not the only one right now. There is local RS, which is very similar thing, which is highly successful. I think I've heard that PubX is the other framework is also trying to do similar things. Then we have so many web front-end frameworks like Dioxus, Leptos, U that are also rapidly growing, getting much more. They're much more used. So just the web ecosystem, while it is not the greatest now, it's rapidly growing. And the other thing is just with how our industry is developing, with the recent strong push to memory safety, to using memory safe languages instead of using the ones we used before. I think that in general the use of Rust is going to be much more prominent, just Rust will be much more used. And with people using more Rust, it will be just natural that web development Rust will also grow as well.
Mm-hmm. Yeah. Maybe in the future we will see something possibly like a new language, right? That tightly integrates with Rust, and maybe part of the applications, like the less important ones, maybe the prototypes modules would be created with this GC-like language that integrates with Rust really well. But some core parts that should be like milliseconds fast would be like in web frameworks that are like pure Rust. Maybe I don't know.
That would be interesting to see for sure.
Yeah.
Thank you. Any other questions?
Yeah, because you could use Django and fill the missing parts that need to be very performant with Rust implemented code. Right?
Mm-hmm. And I think this is just an idea because I haven't seen anything like this. I mean, even like as a prototype.
Incorporate what you just use microservice in Rust
Yeah.
and delegate some
Yeah.
work using HTTP.
Exactly. Yeah. Or gRPC or whatever.
But yeah, the other thing that you can notice in the ecosystem is that the FFI ecosystem is also growing rapidly, which means that more people want to use Rust in different situations and to integrate with different languages. So that also is some type of indicator that Rust use is growing within different use cases that we haven't seen it before.
I think Diaxus or whatever his name, I think it's really great example. Yeah. really works quite impressive also. Yeah, thanks.
Yeah.
Where does the name come from?
It's literally a wordplay on Polish word code. Yeah, that's it.
Yeah, I guess it's
Fair enough.
yeah, I don't know. It was just a meme, so some sort of meme between us two, and yeah, we decided why not.
Yeah. Before being named Code, we initially named the framework Flareon, but after some time we thought that maybe naming a framework after a Pokemon is not the greatest idea. So we thought about different ideas, and I have a cat, so I think this was one of the initial ideas from which the actual idea of the name Code came from, and it just after enough time we think about it, we just said let's just do it, and also we created a nice logo that it fits, it looks nice, let's just go with it. It's name as good as any other one.
The domain is still available for purchase.
What?
And yeah, domain was still available for purchase.
Yeah, it was. But yeah, actually naming the framework after a Pokemon was actually quite funny because there are these quizzes online asking if it's a JavaScript framework or a Pokemon. And yeah, apparently a lot of JavaScript frameworks have names very similar to Pokemon. So yeah, it would be interesting to see Flareon being seen on this kind of stuff.
The funny thing, once we released the framework, someone literally came and, well, do you know that I believe in German it means shit? So you can never go. There are no perfect names.
Maybe this is not the market for you.
But okay. If there are no other questions,
Other question?
yes.
So recently I'm forced to use Spring as a framework, which is very good in kind of modules. So you can add different modules to add different functionalities. And do you divide code into modules like a database module and a web module or template module?
So currently not really. We plan to do that, mostly to increase the adoption. I mean, some people were asking if ORM could be a separate library, and I can't see a reason why not. It's just it was just easier to do it this way. But yeah, we want to separate different functionalities into different modules, and hopefully people will use modules separately from the framework if they don't want to make like a full switch.
And you think like a module as a separate library?
Yeah.
Or there's this kind of feature thing in Cargo when you want to import a feature on or off?
So we already have some feature flags, but no, we think that it will also be useful to create separate like actual crates. Also, this will help with the build times because you will be able to parallelize the builds much more than currently.
And that's at least on the framework side. On the user of the framework side, we don't do any constraints on how your application looks. If you want to do MVC like it is usually done in Spring, go for it. We don't limit you.
So it's not opinionated.
It is, but you can like swap out stuff as well.
Yeah. Opinionated is the use of which crates, which libraries we decided to use for like database, for web server, but the use of the framework should be just simple. Anything else? If not, then thank you for listening.